Good evening, everyone. My name is Supriya Sachdeva. I'm the Secretary of the Executive Committee of Bombay Management Association. So on behalf of my team, on behalf of BMA, I welcome you all to the next edition of Friday Fundamentals. Every Friday, BMA organizes and conducts these sessions. We call it Friday Fundamentals, to promote business management by inviting senior industry professionals who have excelled in their areas of expertise. And we invite them, they share their knowledge, their experience with our members, as well as non-members. These sessions are complimentary, the sessions are free, but the knowledge is priceless. And today's theme is Net Zero Building, a step towards environmental conservation, energy savings, and clean power generation. Now, terms such as carbon footprint, greenhouse effect, these are commonly used terms which are there in our vocabulary. Net zero building is what our today's speaker, Mr. Sachin, he will be covering that. He will be talking more about it. And this is a term which is used as a goal for in the context of buildings. Now we have, it's my privilege to introduce our speaker today. But I'll introduce him in a slightly different way because he has a multidisciplinary skill set. And I think let's do justice to his impressive profile. So I'll start with him being a technologist. At the core, he is a technologist. Physics was one of his areas of specialization as a student. And he is also the founder of Atomic Energy System, which he established in 1989. The company is involved in developing industrial batteries and application engineering, as well as solar power solutions. He has hands-on approach in designing, engineering, and projects. Next, he has an entrepreneurial spirit. And why do I say that? So he's fueled it with his MBA marketing specialization and his solid legal background because he has an LLB degree in commercial laws. He has a record of converting blue ocean opportunity to business and technology solutions. He has 30 plus years of experience to develop untapped opportunities in the marketplace in the niche areas. He has an innovative mindset. His work speaks for that because his company developed innovative solutions for solar powered applications. For example, India's first solar solution for ATM, solar solution for cold storage freezers. They designed wind, solar microgrid experience, a solar forest, solar bottle. I mean, I'm sure he will tell more about it as he goes about it because somewhere renewable energy, net zero building, everything is all interrelated. He's a leader with the qualities of a mentor because he's a visiting faculty with NMIMS, India's top 10 B schools for over 13 years. And he's driven by the quest to learn more. I'm not making that up. He's a research scholar. He's pursuing his PhD in Mumbai University at Jamnalal Bajaj Institute of Management Studies in the 2019 batch. So I welcome you, Mr. Sachin Rele, and it is our pleasure to have you today. And you are from Jamnalal, I mean, you're pursuing your PhD from Jamnalal Bajaj, and coincidentally, day before yesterday, also we connected with the inaugural of this 4-month executive leadership development program, which Bombay Management Association has started in collaboration with Jamnalal Bajaj. The batch 3, I think the 3rd batch is going to start very soon now. And it was nice to see you there, sir.
Thank you.
So over to you. The stage is yours.
Thank you. Thank you, Supriya. I mean, it was really nice to hear good words. And I want to thank BMA and special thanks to Kavita madam for pushing me on to getting this presentation. Before I start my presentation, the whole concept of solar came to me in 2002-2003 when I was actually working on with batteries, and I realized that the whole concept is, how about you buy a car and you never have to fill petrol again? So that's the whole concept. That's what we said. I mean, let the future be in such a way that you do one-time investment and no recurring operating costs. And thereafter the quest started, and in 2005 I actually got my first project for TCS, and thereafter the journey started with solar as a company. So I may sound ancient, but just to tell you, the big size project that I did was in 2006 for Crompton Greaves. The project was a small 6 kilowatt project, and it costed 24 lakhs in those days. Today I can do a 10 times bigger project at lesser cost. So I can do a 60 kilowatt project at the lesser cost. So that's how I've actually seen the project and solar projects transitioning from a peak price to ultimately a low price. And the utility of the project is still the same. So that's where I am. I'm going to take this opportunity to start my presentation. Okay. So the whole concept, we are migrating from the basic concept of zero carbon and coming up to the concept of net zero. I'll explain what net zero means. I'll just take two slides about my company so that we are able to know it. So it started as an Autonic. We are a rooftop solar company. I started working in commercial industrial spaces. We have over 250 installations across. We just completed one 1.5 megawatt project for Reliance Jio for their data center at Ghansoli, which is very interesting and a challenging project. I've also done a project for Airbus in Nagpur, Mihan. In terms of geography, we got an opportunity to do a project in Germany, and the gentleman said, will you do a project in Germany? I said, wherever there is sun, I will reach there. And that's been the motto for us. So thereafter, I did a project in Saudi, in Uganda. The project in Uganda that we've done is for Coca-Cola. And very happy to tell you that I was having a chat with the Coke team. And I said, look, I want to post on LinkedIn about the performance. The person handling, his name is Paul. And Paul comes up and says, no, I'm going to post. I said, you're most welcome to post. It's your plant. So that's how the whole plant thing works. So been in the industry for a long time, the longest time. And I'm amongst the very few players in our segment who can claim about solar projects running for over 10 years. So when people say that what will happen after 10 years, no, I know exactly what will happen because I'm seeing projects which are operating for more than 10 years. So that's what it is. Coming back, I also want to tell you one thing. We have an award from Tata. It's called the Innovista Award, wherein Tata give award to innovative suggestions and ideas for a product which was developed. So this Innovista Award was given to us and Tata Finance for an innovative. We created a solar forest as a concept, and that got appreciated. Out of 1700 entries, 5 entries got recognized. We were one of them, and I'm very happy for Tata Finance team. They called their partner members also to accept the award. So happy to be there. So that's where we are. So now the whole concept is going to net zero or energy conservation is for everybody actually. So the whole project is, we decided that who's your target customer. So the target customer is everybody from schools to bungalows to societies to industrial complexes to commercial buildings to MSMEs to production houses to data centers to place of worship. We've done a project at Siddhivinayak Temple. I have done projects in Gurudwaras and so on and so forth. So wherever there is an opportunity to save, we are happy to be a part of that. So coming back to the topic that we would want to discuss is what is net zero or what is net zero target? So just to put it in perspective, is net zero is a concept in which we say that whatever I'm going to generate is going to be, or whatever I'm going to consume is going to be, I'm going to generate. So my emissions from that building will not be existent. So it will be zero. This is a very big thing to happen because to get into a complete net zero, the opportunity size is going to be $270 trillion. So it's a size which will come in next 20 years or 30 years. So what I'm going to say is the students who are listening to me or people who are looking at it, this is the right field to be in, because there'll be room for everybody, from consultants to designers to planners to town planners to factory owners, to everybody, because this net zero is something that is going to come, and we have to accept it, because with the kind of pollution that we are creating, the only option is to reducing our own individual carbon footprint. So I'm actually trying to come up with this concept of building block what happens is, this is something that I would want to say, is that this is a concept of T of the building block. So when I actually talk of T, this T is about the knowledge of everything. So we have to have a part knowledge of everything and in-depth knowledge of a subject of your choice. So in this case, we need to understand what is the knowledge and how is the building block for. So energy efficiency, passive, active, EV charging is something that I have knowledge, but I'm more equipped to handle solar solutions and energy solutions. So this is where my domain is. And I would want to touch upon all the topics. In fact, I have made it as a case study for electric charging and also for energy efficiency. So the whole idea is that we would want in application rather than just a pure play discussion or display. So what is energy efficiency means? This is a very pretty standard thing, but I would want to see that how it is applied in. So first is that you are talking about reduction of or reducing of the energy losses, finding new sources of power, and obviously increasing the efficiency of the system. So when I'm talking about finding new sources, if you're talking of a building lift, we can actually have a lift with regenerative braking. So this regenerative braking can actually help us to work in such a way that the lift also generates power for all of us. So and this is typically energy efficiency matrix, where we are catering to. First is lighting solution, moving on to LED is good, but right LED is very important. Performing energy audit is the second most important thing, because if at all we are able to know what the losses are, you're able to monitor what your losses are, only then we can actually correct it. Second is improving in for housing complexes. This is the most important thing, is that we need to actually reduce or improve the efficiencies. Hello. Yeah, we need to improve the efficiencies of. We need to improve the efficiencies, and somebody is. Yeah. There is disturbance in the line. Can you hear me?
Oindrila, can you please mute the audience?
Okay, I'll start. So there is efficiencies. Then there is a concept of VFD drives. Most of the old buildings don't have VFD drives. If all VFD drives are introduced, VFD means variable frequency.
Sir, kindly unmute yourself.
Okay.
Yeah, thank you.
Am I unmute? So yeah. So so we are talking about pumps. Pumps are water pumps are one of the most neglected part of the accessories in the building. They sometimes consume more power. Lifts also can be come up with a concept called variable frequency drive. These drives actually reduce the power consumption. Then obviously understand the power requirements. Wherever the power requirements needs to be tweaked. And the last is solar, because solar will help us reduce the carbon footprint in real terms. So when I'm talking about it, I'm also saying that there is in practice. So then when I mean it is in practice, I mean by using BLDC pumps. BLDC is a concept. It's called brushless DC fans. Brushless DC fans, conventional fans consume 60 to 80 watts. So whenever you need to have a replacement, you need to go in with BLDC fans, which are manufactured by most of the manufacturers like Havel, Crompton. They are manufacturing it. And the most important part is that once you do that, the electricity bill for the fans goes by half. You reduce it by half. Second is buying good quality LED lights are also important. Always use 5-star appliances wherever possible. IoTs, Internet of Things for air conditioners and other power operations. Check the leakage. And one more thing which is missed by most of the corporates and the housing society is that nobody actually checks the earthing values of the system, because there is leakage into the system. So these are all small things. If you are able to incorporate, there is an immediate 10 to 15% savings in the electricity, and of course reducing the carbon footprint. The second part of the building block T is the passive strategy. And the passive strategy includes how do we, this is for newer buildings, how do we introduce the climate response and manage the window to wall ratio. I have shared the link. This link will be useful for those students or people who are wanting to get more information. Wall to window ratio is very important to reduce the emission, also attract more fresh air, and the orientation of the system. Second is building enveloping solutions, which includes the reduction of the thermal masses. And we're also speaking about high performance reflective glazing. There are some amount of glazing which actually creates hotspots in the building. So if you design the system well, the hotspots are reduced and the light is there. The final outcome for the whole process is to ensure that we actually reduce the energy demand by increasing the efficiencies, or by getting in natural lights, natural ventilation getting into the system. So this is a passive strategy when you are developing a new building. When you are repairing the new building also, there are some strategies which can be incorporated. Like I mentioned to you, this is the T part. This is the linear line of the T, where I only want to give you information so that you can actually go into the depth and get more information about the specific topic. Second is rainwater harvesting is something that is important. It will not only increase the tertiary water level standards, but it also reduces the water demand. And the next important part for my friends who are into landscapes, going for plants, right species of plant. When you mean right species of plant, is plant obviously which are native to that location, and some plants which are drought resistant. So if at all we are able to get those plants, obviously they'll consume less water. They will keep your area green and nice. And the one prerequisite for this is only use treated water for irrigation. So which means recycling of the gray water is very important. And wherever we have an opportunity, treating of this water is important. Then we come to what are the active strategies into the system. First thing is, whenever anybody wants to get into the air conditioning system, we need to focus on the right and precise temperatures. The VFD, we can go in with VRV type of air conditioners, which are specific to a particular location. So the temperature can be controlled. See, lower the temperature, higher the electricity bill. Then using of sensors, then the intelligent sensors for temperature, for fresh air. So if at all the building has an opportunity to get in fresh air, the right fresh air needs to be coming to the system without injecting into the system. Most of the offices we have seen that the fresh air is induced into the system. But there are various ways in which you can look at the fresh air coming in without any inducement. Second is bidirectional heat recovery. There are heat pumps which actually recover the heat from the system and actually get into with allowing us to have a fresh air change. So heat transfer is also very important. After the session, in the questionnaire, I'm going to ask a question. The question is that we've all been in the lift. Can somebody tell me during the final question and answer session, when does the lift consumes maximum power? This is a question that I'm asking. So when does the lift take maximum power is the question. Whenever the question answer session comes in, I'm happy to get a right answer from you. Second is filtering of incoming air. Then, of course, I mentioned about CO2 sensors are very important, because where the CO2 concentration levels are higher, we need to ensure that the levels are reduced. The classic example is in the car park, or in the location where when you go to a mall, and when you to the car park, you see that there is a very peculiar odor that comes into the system. So that odor actually increases the stress, and it increases the stress, resulting into the whole system getting stuffy and claustrophobic. Then, of course, real-time sensors to manage volatile organic compound and humidity to get out of the system. And of course, the most important thing that we need to have in a house is a plant to keep fresh air and obviously add aesthetics to the system. This is something that I've already discussed. Typically, managing of lux level, which is very important into this into the operation. And ensure that the right luminosity is there. There are standards for the luminosity of this of the room. So there is a 10 lux level which is there from highway, 350 lux level for a table. So everything, there are specific standards. So we need to calibrate each of it based on the individual occupant's requirement. This could actually increase the savings to up to 64%. Water efficiencies, like I mentioned to you, waterless urinals. We could go in with high efficiency sensors, and energy monitoring from production to consumption. If everything is managed well, the whole system will be operationally successful and can do a great job. Next is on EV charging. Most of us know that we are getting into the era of electric vehicles. And what I've tried to do is a test case on EV charging, because we would not want the coal energy to come in and charge the electric vehicle and try to be perceived green. So I have actually created a case study of how the system would operate. I've taken a case study for Tata Nexon. The Tata Nexon's range is about 312 to 437 kilometers. If for one full charge, it requires 30 units of power. So at 30 units of power, which is effectively the rate is about 8 rupees. So 240 rupees, the battery will get fully charged, and you're good to go for 312 to 437, depending upon. So what we've done in this case is that I have assumed a certain fact that let's say there is a person who commutes to office, has a 60-kilometer office commute, which is 30 kilometers one way. The whole 312 to 437 kilometers average is about, we assume that for every time when he fully charges his car, he can actually operate for 5 working days. So then we have the concept of net metering, or introducing solar solutions to ensure that the net metering thing operates. So this is the case study that I would want to work with. So let's say there's a housing society. This is a residential complex with one car. We can go with one charger. One charger will need about 30 kilowatt of power, 30 units of power. So it's a 5 charging days. So to get into that net zero B as a concept, we would need a 7.5 kilowatts green energy, which means solar project will about 7.5 kilowatts. It will need 600 square feet of space. Now, in 2 years time or a 3 years time frame, if the number of cars goes from 1 to 5, then we would not need 5 chargers. We would need only 2 chargers, because it's going to be cyclic. And the total power requirement per day is going to be about 60 units. And we would be happy to, this whole thing will be supported by a 10 kilowatt system. And the total area is about 800 square feet. So this could be for residential, offices and malls, essentially more importantly for residential and commercials or offices. Now extend this whole logic to typically 10 cars. So there will be 10 electric cars. The whole charging cycle for a car will be about 3 to 4 hours, not more. So it can be cyclic. So So if you're talking about 10 cars and we have 4 number of chargers there to be addressed, the total power requirement will be about 120 kilometers. Charging cycle will be variable because not everybody will be able to come for charging at the same time. So I would propose a 30 kilowatt system. Total area would be 2,400, and this will be most suitable for a large office complex or a mall. When we look at it, the following observations have to be looked at is what is the type of vehicle that we are talking of. So if it's Tata Nexon, it will be different. For a Tesla, it will be different. Road conditions play a very important part. The second question that I would want to ask you is if you can keep this open, Andrila, if you can keep this open.
Yes, sir.
What is the power requirement? What will be the power requirement for electric vehicle in a condition where there is a lot of traffic? So this is something that is the second question. Whenever the question and answer session open, this is the second question that I would like to ask the audience. The third thing that I would want to discuss obviously is the concept of called solar solutions. Now, most of us know how the solar solutions work. Solar energy, solar photovoltaic modules convert energy. From converting energy to convert energy to a circuit breaker, there's a bidirectional charger. From bidirectional charger, it goes to the power goes back to the load, or it goes back to the utility. There is a net metering concept. This net metering goes very simply. Whatever the surplus energy which is generated goes back to the grid. Whatever is accepted by the load goes to the load. So whatever energy that you are generating will be consumed by the load first, and only the surplus energy goes back to the grid. So whenever we want to select a solar installation, these are the 4 important points that we need to look at. First is understanding the load profile. So if there is a factory, we need to understand what kind of heavy machinery it has, whether it has a lunch time, what is the time of the day operating cycle, what kind of roof is available, with whether there is a tall building overlooking it, causing it shadow over the roof. Because solar energy, we are very clear, when there is a solar energy, obviously the bigger concern is that when there is shadow on the roof, on the solar modules, solar is not going to generate. The next question comes on is the electricity bill. So every state has a different electricity policy. So for Maharashtra, let us say if you have a connected load of 10 kilowatt, then you can go up to 10 kilowatt of solar installation. So if the capacity, so for a typical residential house, for a 2-3 bedroom house, the typical unit consumption will be about 600 to 700 units. So 700 units is when you have your air conditioning and normal things out. So maximum will be about 700 units. And somebody would pay something like between 7,000 to 8,000 to 10,000 rupees as the monthly outgo. And last is the structural stability. This is more important for an industrial structure. And when we're talking about the industrial structure, is that there are industrial roofs which are GI sheets, whether the sheets are able to take the additional load of solar modules. So when you look at this as an holistically, there are many people who come to us and saying that, okay, I have a huge balcony and can I put solar on the balcony? The answer to that is that if the balcony is south side and if there is no shadow there, then the system is very, very much doable and we can install it. But if you are on the east side or on your on the west side, the system will not be operating. So we cannot actually install the system. So the first prerequisite of the thing is that we need to have clear shadow-free area wherever we are in, wherever the solar is to be installed. This is something that I would want to dwell on. So I'm happy to take as many questions on this, because once you understand this, everything becomes simpler. So how can a society benefit, and how does a society operate? So we can actually operate, now to put it differently, what actually happens in solar energy is that there are two powers which are there. One is the grid power, which is the coming from the electricity board, and one is the solar power. Both of them combine together. When they combine together, the system is designed in such a way that solar power gets consumed first. So let me give you an example. Let us say you have a bungalow and there is a 10 kilowatt system, solar system available, and there is a 10 kilowatt load which is available, which means assuming that you have got 4 ACs, all 4 ACs are on full blast, all the lights in your building are full blast, and we are talking of a morning time. So let's say you are at 12 noon. So at 12 noon, solar is generating at maybe 8 units of power, and the requirement is for 10 units of power. In that case, solar will feed the whole load to 8 kilowatt completely. So 8 kilowatt will be powered by solar. The balance 2 kilowatt will come from the grid. In this case, to simply put it in perspective, is that the person who has already invested in solar will only pay for 2 units of power, not for 10. Because the 8 units are first consumed by the grid, and those who are from the electrical background, the answer to them is that the solar energy is designed to manage on low impedance load, which means load is always lower impedance than the grid. So the grid will be not addressed, the load will be addressed first. These systems are batteryless systems, which means there are no batteries into the system. The energy that is generated is directly consumed. The surplus energy which is generated goes to the grid, and it is stored in the grid as per the state policy. In Maharashtra, let us say that, let's give you another example. Let's say that you are on a 15-day holiday in May. May is the brightest of the sun times and where you have maximum energy generation. And let us say that you have generated 10 units a day and you are out for 15 days. So 15 days into 10 is 150 units that we have generated. This 150 units will be kept in your bill. You will get credit for 150 units. After you get the credit for 150 units, let's say in subsequent months, whenever you are actually not generating or whenever there is low power, let's say in month of June, or let's say a day like today, for those who are in Mumbai will know, the generation will be at 20 to 25% of the estimated capacity. In that case, your ACs and everything will be on. That credit of those 15 days, you will get it today. So if you're talking about educational institute, Saturday, Sundays, on holidays, when they get that credit will be passed on to a day when there is less sun. So coming back to is, since I've explained to you that the power gets mixed up, and it can power all kind of load, which means your elevators, your pumps, your lights, your clubhouses, and all air conditioners. All the loads can be completed. And what are the prerequisites for that? Only 2 prerequisites. First is your shadow-free area, and second is whether your building is able to take this weight. Solar load is not very high, but it is always a best practices to ensure that the infrastructure that you are going to put solar on is supported. The second point I also want to share with you is that the life of the solar plant is 25 years. We do not want to change or change the installation because there is a repair on the floor to be taken. So that is the second thing that we would want to. And what is that I require from you? I require only 2 things from you to do the assessment. First is the electricity bill, and second is the Google coordinates. So if I have the Google coordinates, today we have mastered the art of giving you virtual reports based on the requirements, and after the requirements are studied, we come to a conclusion and saying that this is the capacity that is most suitable for you, and this is how we design the system. This is a housing society that we've designed. So this is the initial study was done on using Google Earth. This is a society in I think Bhinder. This is Viceroy Society in Bhinder, where we have done this installation. This is a bungalow that we have done in Manor. This is a commercial complex. This is Thana Municipal Corporation where we have done, and this is a residential. This is a small commercial complex. When you see, we have actually installed it on an industrial roof. So these are the various kind of installations. The good part about solar installation is that it is perfectly retrofittable, but it needs a lot of design engineering to put it. So I always give this very crude example for us, is that let's say I have the world's best harmonium with me, but I can't play harmonium. Just because I own the world's best harmonium does not make me the world's best player for harmonium. So the concept is that most of the cases solar modules are available, they operate very well, but if it is not designed well, the system may not generate to its peak efficiency. And this is something that is very important. Solar projects are not commodity. It has to be engineered based on the requirements and based on the design parameters of the system. So how does the solar financing work? So there are two aspects. For a smaller system, we can actually have a 100% investment, because typically solar investment has a payback of 3 to 4 years. For industries, it is even more beautiful, because the government of India, the finance has actually offered 40% accelerated depreciation into the system. So based on that 40% accelerated system, you can further reduce the cost of ownership. A typical solar investment has an IRR of greater than 20%, and it is all documented. And the next is the EMI model. When we talk about an EMI model, we have an EMI model where it is 70%, cost is borne by the investor, and the 30% is borne by 30% is borne by the customer. And its typical payback period is 4 years. But I mean, we can have it can be done financed by a bank or a financial institute, as the case may be. I would want to next go to a case study that we have done for. This is a building called it's Neelkant. This building, before the installation, it was something like this. When we looked at this building, this is another building that we've done later on. So this is how we designed the building layout. Based on this building layout, we have realized that it's a cooperative society type of structure. Some of it is flat galvanized structure. It's a 30 kilowatt system. It is installed in 2017. This is the inverter specifications. This is how we actually placed the solar modules on the roof. So see, if you look at it, these are the shadows, and we've actually done a shadow analysis for the roof, because this is the overhead tank, and based on the overhead tank, the shadow analysis has been done. After the shadow analysis has been done, the project is installed. So if you can actually appreciate this point, prior to the installation, the electricity bill was 3,600, 3,700 to 4,000. So it was installed in 17th of December, and the bill has reduced to 505 rupees. And you can see the curve of the generation from 2000. I can show you the generation data for today, because once you install the system, we ensure that we monitor the system on real-time basis, on daily basis. So this is how the generation goes. And this is the specifications or return on investment for the project, wherein the investment was 19 lakhs and the payback is in 4 years. And this is how the system has generated. So to 30 kilowatt system, we talked, in this case, there is an IRR of 28%. The total savings is 96 lakhs on an investment of 19 lakhs. So it's nearly 5 times the savings that has come in by installing of solar projects on the roof. And if you realize that this depreciation of 40% for a housing society is not factored in, so if you factor in a 40% for an MSME, this savings will be further higher. This payback period will be further or lower than 4 years. So we also have an EMI for housing societies, and we could take it offline for those who are interested in. Then comes energy storage. Now, energy storage is a field wherein whatever the surplus energy, it's energy that is generated. The surplus energy will be fed into an energy storage, which is a battery. and the battery will be feeding it up, and that's the whole concept of energy storage. It's too early for energy storage to be accepted, but maybe next 3 to 5 years energy storage will be the topic of the day or flavor of the day. And if there is any specific requirement or anybody wants to understand more about energy storage, I'm happy to address it and work around it. Now, this is something that I am very interested in. We want to develop the concept of solar trainer. In solar trainer, it is going more like a CSR where we can actually train you on the presentation, and you can go to schools, colleges, and other places wherein you can actually promote the concept of solar activities and develop it. It's more of CSR, just like a presentation to sensitize the young generation to a lower carbon footprint lifestyle. And this is a lead generation. We welcome to work with partners and develop the projects together. So I am ending my presentation. I'm happy to take your questions.
Thank you, sir. Thank you for an in-depth presentation and coverage of the topic. So while we await the questions from the audience, I request the audience to please share their questions in the chat box. While we await for the audience questions, I'd like to understand something from you, Mr. Sachin, if I may.
They're saying my voice was not audible. Most of them.
It was audible, sir. It must have been their audio system, because I got it checked from others also. You were audible.
Okay.
No, it's audible, sir. No problem.
Yeah.
I have a query, sir.
Yes.
I have noted a number. I'll contact you separately tomorrow.
Yes.
You are only into the rooftop solution, or also you do ground-mounted solar?
We do all solutions. Yes.
Okay. And you are the owner, sir? Sorry
yes,
to ask
I'm
that
promoter
question.
of the company. Yes, I've promoted the company. Yeah.
I joined late, actually. Sorry for that.
Hello.
And sir, now the solar module prices are stable. If you see last 1 year or 2 years since lockdown. So when you give the quotation offer, what will be the validity? Because the project execution is normally high, like 3 months, 6 months. So module comes later on from China or Singapore. So the price fixation is something is fixed, or it is slightly dependent on some factors, and what if it is so?
Can you please introduce where are you from, and so that I can actually get the context?
Yeah. Actually, I'm from Kolhapur, and currently I'm in already renewable space for around 23 megawatts.
Okay.
So we have wind and solar both.
Okay.
So we want to add some 2-3 megawatts.
Okay.
But probably it will be ground actually, because roof पे इतना कोई अभी scope नहीं है. मेरे factory वाले roof पे मैंने लगा दिया है.
Sure. I have a very good and old system in Kolhapur, which we have done in 2013, 14, 15. It's working beautifully. Anyway, so the answer to your question is, if you want me to be very blunt, Government of India has put up a 40% custom duty for solar panels from 1st of April.
That is dangerous. Very bad actually. Sorry.
Yes. First. That is first. Second is you cannot import Chinese model from 1st of October.
Achha, there is another shorty now.
Yes, sir.
So now you are totally procuring Adani and Vikram and local, or Tata, and you are importing also?
We have done all kind of works. Just to put it up, have you heard of a company called Renewsys?
Yeah. I've heard. I've seen the ad in the magazine actually.
Okay. I have installed 1.4 megawatt on the rooftop, sir. And rooftop ground mounted everywhere. So we have got 1.4 megawatt installation in Renewsys in their factory with their modules.
Okay. So how is your feedback?
Fantastic.
The output?
Very good.
So the module is on the latest technology. What you say, photovoltaic new one, or what is the technology?
Now the current technology that we are going in with is with monoperk half cut.
Okay. Cash flow. Yes, sorry, sir. Some interruption was there.
Half cut.
Half cut. What is that, sir?
you call me offline, I can give you the whole information about it.
Okay, no, I got the brief. Actually, in that lesser square area, you get higher output.
That's right.
Actually, I got it.
Half cut is a different technology. Half cut is actually when you put two cells together, when you connect two modules in parallel, the resistance goes by half. So the efficiency increases by 2-3%.
Okay. Sir, actually, I am also having my friend and one of my sister concern in one startup company also. So there are a lot of new players are coming up with some creative ideas. तो एक बंदे ने एक presentation दिया था recently in the Google Meet. आपका जो window glass होता है, they put that solar that film or strip in that glass fusion, something like that.
Yeah.
And they do that power generation, and that office, that corporate office or that whatever building becomes self-reliant, power friendly.
That is called BIPV. We can do it. It's called BIPV. It's called Building Integrated Photovoltaic. And we have not done it because it's a little expensive, and it does not have return on investment. So,
okay, sir. So I've just taken a screenshot of your details of the company and all. I think that mobile number is yours, sir.
Yes, it is mine. Yeah.
Okay, I think Mr. Sachin Rele.
Correct.
Okay, sir. I'm Sangvi here. You can note down. I'll call you too.
Certainly.
We have done our solar right now. Some project we have done with Pune, one company, Enrich Solar. Correct. And one project we had done from Jaipur, Rajasthan factory, from Solar 91.
Okay.
Yeah, and then we had got multiple quotations like Race Solar, then Sterling Wilson. A lot of people are quoted.
I'm sorry to interrupt, Mr. Sangvi. Hello. Yeah, hi. I'm very sorry to interrupt, Mr. Sangvi. I think what we can do is we can take your questions offline, and Mr. Rele has shared his contact details with you, because we are getting some questions from the audience also. So shall we move on, sir?
Yes, please.
Okay.
Sangviji, please connect. I'm happy to do that. Okay. Just to. Yeah. Tell me.
So one question is, and I'll tell the question as it is. So can solar models price be budget friendly in future? But I'll also add to this question, the solar subsidies and the government, the way government pushes, the whole focus. There's a lot of push from the government of India. So, and of course, the pricing, it varies depending on, like how you said, you cannot import something now. That means you're relying on the domestic manufacturing. So how do you see the pricing variations going forward, and how much? And I'm sure you're seeing the returns, like you said in the beginning, that there are installations which you're seeing for more than 10 years now. So there is definitely energy saving, price, the cost and everything. But still, what is the trend? What is it that you'd like to say about going forward?
We are in a very competitive market. So what government is trying to do is trying to encourage Indian players to come into it. So that's the first thing, which is a positive. But we are against, or we are worried about the cartelization, which may not happen. So ideally, the prices will increase by about 5 to 10%, but I don't think it will be increasing super normally. So where the payback period is going to be 4 years, it can be 4 years and 2 months. So it cannot be 7 years. So then the project is unviable. So it's just a temporary phase wherein the policies have just come in, and we're still digesting the concept. In fact, the Indian module note came on 1st of October. So it's just 15 days since that note has come in. So yes, we're trying to adjust it. So
okay.
So prices will not be off.
Okay. What is so we have been talking about solar, of course, for decades now, and the specific term like net zero building, how is it, in what context is it different from the terms that we have been using earlier? I mean, how does this change the perspective?
What I feel is solar today, it cannot be looked at one part. It cannot be only solar. It has to be an ecosystem. And what it's like everybody's doing their own part. It's like it's like your a mala that we have. They're separate beads. So what net zero does is it entwines all the beads into one and says this is what net zero is. So energy savings, passive strategies, active strategies, EV, which is going to come in the future. So just to put it up, to have an EV infrastructure in Europe, the statistics goes that only to have an only EV infrastructure only in Europe, they would require an investment of $400 billion. Okay, so that's the reason. So people will say, okay, tomorrow you want to switch into EV. Sorry, that's not going to happen. So what we are trying to do is, India is a very, very massive market, and we are very regional players, and it's very fragmented as we know it. So what we should do actually is that, okay, you want to go in with EV, okay, put up a EV charger, put up a rooftop solar, and you're good to go. And that's how the whole thing will propagate. So we did a project in Germany, right? So when we actually went into Germany, my team was buying those data cards. And in Germany, having a 2 GB data for a month is a big thing. And so we were just laughing. In India, we say we consume 2 GB a day. So that's what leapfrog is all about. And that's what India will leapfrog here. So we were very conservative of using our 3G or 4G there, because 2 GB saal mahine mein kharcha karna hai. So India use 2 GB a day, believe me. So that's where it is.
So in short, you're saying that it's not really a very coordinated effort so far, but it's in piecemeals. It's in the building blocks are there as and when the requirement comes up, but eventually it will lead to more of a net zero solution.
Somebody has to stabilize it, right? Somebody has to put everything together, and that everything together is NZB, as they call it. This NZB will be the defining moment. This will change the complete way of we thinking and even building it. So architects, town planners will actually have to start thinking on a 360 degrees, wherein we do not increase more carbon or emissions into the system, where it will be completely zero. So India has actually signed on COP, and we have actually committed to net zero by 2070. Government of India is saying that by 2030, today we are at 60, maybe 80 gigawatt of power through renewable energy. Government of India has said that we will go to 450 gigawatt of power by 2030. So from 60 to 450 is a huge leap. And just to give you an answer, and I want people to get excited by the numbers. 1 gigawatt is $1 billion approximately.
Sorry. Yes.
So 1 gigawatt is approximately $1 billion. So we are talking about 150 gigawatt of power that has to be coming in, and we are talking about 270, which is all things to put together, and that's where we are. So the numbers are really large. Have I addressed your question?
No, yeah, I get a gist of it, and I was actually wondering what is the India's take globally, as in on this. But you mentioned it yourself about the India signed the COP and the targets by 2070. I think you mentioned that, right?
2070, we are going to be net zero. And today, just to answer one more question, is that India has 384 gigawatt of total power generating capacity, of which 80 gigawatt is about renewable energy, and we are going to grow at this rate. So most people who want to get into solar or renewable energy, you're most welcome to join.
I'm still trying to piece in one part. So I've heard, so for example, I know that there are subsidies for renewable energy in different aspects. Solar will have its own, then there could be other like wind power or anything. Net zero solution on the whole, has government, is the companies in India, I'm talking specifically from the Indian context, are the players who are striving, especially in the commercial space, to achieve net zero building solution. Are they driven by on their own, or is it some mandate or is it just that we know that government is giving subsidies, so yes, it will? What is the push? Where is that push coming from? Internally, externally, mandate, voluntary?
Currently, first is that there is no subsidy for solar. Okay.
Now there is no subsidy.
See, because in 2012, when we went to meet the Secretary MNRE, that is Ministry of New and Renewable Energy, and we asked for 30% subsidy. And I'm very happy to tell you that I am one of the smallest players in the industry, and it's being very humble about it. I have received a subsidy for our customers to the tune of 2 crore rupees. So when people say subsidy nahi aata hai, I am completely against that, because we have dispersed 2 crore rupees subsidy, and because we were a ministry approved channel partner, so we were the conduit. So we used to execute the project and pass subsidies. So we've given subsidies to Sidco to 47 lakhs, to a builder in Pune for which is 45 lakh rupees. Shopper Stop, where we did a project in 2012, they've got a 10-15 lakh rupees subsidy. So all of them have been dispersed and they've received the subsidy. At that point of time, the Secretary MNRE, Sri Deepak Gupta, very clearly said, fine, I'll give you subsidy. That's not a problem. You tell me what is the sunset clause for the subsidy.
Okay.
And at that point of time, we said, okay, price parity. Because at those time, the price parity was not thinkable. And believe me, we got price parity in 2016, and 2018, the subsidy stopped.
Okay. Okay.
Because
I knew about the subsidy being there, but I didn't know that it has been
it's
stopped.
no longer there. It's for residential houses. That's about it. There are no subsidies available. But government is still encouraging industries by giving them 40% accelerated depreciation. So most of the cases, we have a depreciation which is 15, 20, 25%. Here we have 40% accelerated depreciation for now. When we started, it was 100%.
Yeah, there's a sunset clause to that too, I'm sure. Great.
So my question that I asked,
yes.
nobody answered. Has anybody answered that question?
So when I think your first question was that when you're in a lift, at what point does it consume maximum power?
Yes.
Okay.
Yes.
For what little I understand, I have some guesses, but okay, we have some answers while going downwards. You can wait for some time, maybe listen to my answer and then embarrass me. It's okay.
Sure.
Okay. Okay, so we have received one answer while going downwards.
Okay.
Again, while going down, that could be I was thinking maybe every time you initiate, you trigger, that's when it consumes more power, irrespective of whether it goes up and down. But I think you have the right answer.
I'm only telling you because we did this experiment, and it's come from an experiment. So it's
okay.
It's you want me to tell you the answer now?
Yes, let's hear it.
So what happens is lift works on counterweights. So whenever an empty lift comes from top to down, it consumes more power.
What is it?
Yeah. So we did a project for NRI Seawoods in 2003-4, and in 3-4, when we realized that the system was designed to operate for 6 hours backup, we gave them an UPS to operate their lifts. So the whole system was designed for 6 hours. Since my past experiences in batteries, the whole system used to work for 8 hours, and I was at shock. I mean, it should not. I mean, I cannot over-engineer a project. So when actually checked the readings, and we realized that when the empty carriage comes down, takes the maximum power. Because the counterweight has to be pulled against the gravity. When the lift comes down, the counterweight has to be pulled. So that is the time it takes maximum power. Some gyan for you.
Yes. Great. And you had another question. I think it was about the power requirement of a vehicle.
Electric vehicle, yes.
Electric vehicle in traffic. Was it specific to traffic?
Yes. What happens in traffic? Yes.
So any questions any answers from the audience? So while we await for the answers, I'll take up one or two questions from the audience.
Yeah, sure.
So there's a question from Mohit that in a factory or maybe in any setup, is it feasible to connect each and every machine which is running on normal electricity to connect it to renewable energy like solar? Or how does that feasibility, is it fine, or is there any feasibility analysis?
That's a good question. So there are two ways of addressing this. First is when we talk about a grid-tied system, and second is a battery-operated system. So when you talk about a grid-tied system, our solar project gets connected to the main incomer of after the meter. It gets connected to the main incomer. So when it gets connected to main incomer, like I mentioned, both the powers get mixed up, and you don't know which power is powering what. So because it's mixed up, we can actually connect it to every system in the factory without any problem. Okay, and I want to add one more thing, which is with reference to this, is imagine there is it's 12 noon and it's full sunny, completely sunny, and this is limitation of technology, and if somebody asks me a question, I will tell you why. And there is a grid failure, there's power failure. The system is designed to stop generating. This is the technology which is available. The system will not generate. Does anybody want to know the answer? From the audience, Sophia, not you. Have you got any answers?
Okay. Maybe, no, not yet, sir.
Okay. We can wait for the next question.
There was another question actually. Connections. So I think I think the question again is from Mohit only, where he's inquiring if we can completely do away with the electricity connection outside the city area when you already have a solar panel installation, which is like completely going off grid, which is a solution. But I'm sure there must be.
Yeah. Now let me answer this question. See, yes. What happens is whenever you are connecting solar power, like I told you, you mix the power from the grid and solar together. Because what happens is in a factory, and this is specifically for Mohit, in a factory, what actually happens is that you need steady power and you need a reactive power as well. So when you talk about reactive power, which means there is, let's say, a lathe machine, there is a drill machine, there is some cranes which move in, that needs torque, which means high current have to be done. That high current is not possible to generate from solar. So because of this concern, we need to have a reference voltage. So you cannot go off grid with solar, but you can reduce your power consumption with solar. That's the thing. So if at all you want to reduce it, there are solutions where we have a DG solar grid hybrid, which means we can actually integrate DG grid and solar together, but that's not the best things to do. So you cannot go off the grid, but you can actually reduce the bill completely. Like I said, I mean, for this building, the capacity has gone from whatever to zero if it is designed well. So, Mohit, have I answered your question?
Yes. There's another question which is related to shadow, but I'll also add something to that. Whether solar panel will produce any electricity in shadow or will it not produce? Of course, shadow does affect the efficiency of the electricity or the power generated. But if you could please answer that.
So there are two aspects of shadow. One aspect of shadow is yes, it will affect the generation. The second aspect, which is even more, if the modules are half covered with shadow, then it destroys the modules in the longer run. We call it hotspots, because a module is like a multiple cells connected together. So imagine there are some cells which have solar power coming onto them and they're generating. So those modules which are generating, or those cells which are generating actually gives power to the cells which are not generating, thus affecting the performance of those cells which are under shadow. So it's not the best thing to do. So there are many times I have faced this whenever we go to a customer and we say that, okay, X capacity is possible. So to put it up in example, let's say that we are talking about 20 kilowatt is possible. And a customer tells me that, Arey, your competition has given 30 kilowatt system. So it's not about the area available. And I keep on telling them, look, I'm here to sell. More selling is better for me. But it is not feasible to do it. So the most important thing is that you cannot have modules partly covered with shadow, which will destroy the modules and warranty in longer run. So never have.
I'm sure you must have faced this challenge while working on projects. I mean, there's no workaround to that, I believe.
So we just reduced the capacity of the module. So we did a project in Assam. The capacity ordered was 600 kilowatt. And we realized that we couldn't fit more than 560 kilowatts. So the capacity was reduced to 560. And that's how the project went through.
Okay.
So cannot do it. I mean, it's not, it will actually destroy the system. So.
Okay. Great. I saw a question related to career opportunity. I think that's a direct question from your company point of view, whether you're providing if there is any career opportunity and if you're providing any training.
We have internship programs and we're happy to get right talent for internships. He can actually apply to us. We're happy to.
So Rajesh, Mr. Sachin Rele had shared his contact details. If you need it again, let us know, but you can directly get in touch with him. Great.
So let me give you one more.
I think we've covered.
So like I told you, we're looking at future as an aspect. We've floated a company, which is very ironic, but yes, we floated a company to give solutions for solar on floating water bodies.
I was thinking I'll ask you, what is the floating technology in the renewable space? Because I know that you're interested in that. So
the question here is that you'll be surprised. India has 18,000 square kilometers of floating or water area across in various cities, and 18,000 square kilometers. So I want to put it in perspective. You know what is the area of Singapore? 724 square kilometers. Okay. So Singapore is 724 square kilometers and India has 18,000 square kilometers of water bodies.
Water body.
Yeah. So if at all we are able to cover 5% of those water bodies, we are talking of generating 288 gigawatt of solar power. So today India is 384. We can generate 288 gigawatt only by using 5% of water bodies. So that's the new technology. And I've been working on that technology since 2016, and we've just got a new company. We're trying to raise funds for that, or equity for the company. So yeah, that's what it is.
That's really interesting.
It's newer concepts that have to come in, because tomorrow energy will be a bouquet of power. So you cannot just say solar or wind. It will be bouquet of wind, solar, then thermal. Thermal means water heating, CSPV as we call it, then wave energies, and everything will come together to form a bunch or a bouquet of power generating resources. So that's where we are.
Great. I think we have a question from Mr. Prakash. He's raised his hand.
Yeah.
Mr. Prakash, please go ahead and ask your question.
He's on mute.
We've asked him to unmute. So while we await for his question, could you please answer the question that you had posted for us about the power requirement for a electric vehicle in traffic?
So what happens is, in electric vehicle, it operates on batteries, right? So when it is parked, there's no battery is not working. So it's off. Unlike a conventional vehicle where your car is on fuel and you put it on and you have to start it or switch it off. In this case, it all goes on auto sleep mode. So only the air conditioning load which is on may be on, but so the loss of battery is never there. It was a trick question.
Interesting. Great. Great. So it was, I'll conclude this session now. I think we've attended to all the questions from the audience so far. So thank you very much for bringing your perspective, your experience to our audience. And I'm sure, I mean, if audience has more questions, you have shared the contact details, or we'll be happy to connect them with you. But thank you so much for taking out time for preparing this presentation. And I'm sure it must have taken a lot of time, but it was worth it.
Absolutely. Worth
Thank
it.
you so
Thank
much.
you so much. Thank you, Kavita madam. And
on behalf of Bombay Management Association, I'd like to thank you a lot.
Thank you. Thank you. It was a pleasure interacting with you.
Sir, can you just tell your phone number again?
Yeah,
Mobile number,
98205.
We'll share it in the chat
98
box. Okay.
205
98
205
98 205
27274. 27274.
Okay, because screenshot. Yeah, because that screenshot, that figure is very small.
Okay.
Okay, sir. Okay, sir. Thank you.
Okay.
Thank you.
Okay. Take care. Bye bye.
Okay. Thank you, sir.
Bye.
Thank you, everyone. Thanks.